In the first week of February 2022, NASA revealed a fine collection of images that were recorded by JWST, the James Webb Space Telescope. These images mainly portray the early stages of 18 important mirror segments of the telescope that are properly aligned. By cautiously pinpointing the telescope at a vibrant, isolated star, the HD 84406 in the Ursa Major constellation, the final image mosaic was formed. Each specific dot that is located in the image mosaic has been carefully labeled based upon the corresponding primary mirror segment that captured the same. The reason behind choosing this star over millions of others is that one can easily identify it. Also, the star stands apart from the rest since it's not overly crowded by the other stars that have a similar level of brightness. This in turn also helps to reduce background confusion. All these minute details were reported by the U.S. Space Agency in a statement later that day. As a treat for the summer, we got an important update in the form of these blurry images that helped the great minds of NASA to align and focus the JWST to capture some fascinating views of the universe. The principal investigator for the NIRCam instrument and an honorable Regents Professor of Astronomy at the University of Arizona, Marcia Rieke, recently stated that the whole Webb team was rejoiced over the initial steps of taking image mosaics and arranging the telescope according to it. Everyone there seems to be thrilled to watch the way that light makes its way in the direction of NIRCam. Within the next few months, NASA scientists will successfully adjust the mirror segments to obtain one fine star image from these image collections, reported NASA. They started to capture the images on February 2, 2022. Since then, the JWST has been altering its positions more than 156 times, trying different positions, especially around the predicted location of the star. As a result, nearly 1,500 images were generated with the help of the NIRCam 10 detectors. On the whole, the raw data was about 54 gigabytes. With each of its mirror segments, the observatory was able to accurately find the target star in less than the first 6 hours and 16 exposures. After collecting these images, they aligned and attached all of them to generate a solitary enlarged image that can effortlessly capture the signature of each primary mirror segment in a single frame. The deputy telescope scientist for James Webb Telescope, Marshall Perrin, gave a brief note about Webb, stating that the initial search was able to cover a space the size of the moon, as the segment dots appeared to be widely spread out on the sky. This telescope, worth about $10 billion, is expected to go beyond our imagination and explore every nook and corner of cosmic history. Thus, with the help of Webb, we will know more about our solar system as well as the whole universe.